Yeah, good evening. Yesterday, I given object-oriented programming introduction. Okay. Java is object-oriented programming language or Java is object-based language. Object-oriented programming language. Okay. Object-oriented programming language and object-based language. What's the difference? Without including inheritance and runtime polymorphism, that is called object-based. Including these two called object oriented. So Java comes under oriented. Okay. How many principles are there? 4. What are those? Encapsulation, abstraction, inheritance, polymorphism. 4 principles. Okay. Java supports 4 principles. If you want to learn these 4 principles, first of all, what we require? Class and object. Okay. What is class? Class is a collection of variables and methods. Okay. Class is a collection of variables and methods. Okay. But don't give class as a plan. Okay. Class, understanding purpose only. So class is a collection of variables and methods. Without class, we cannot create object. So without plan, we cannot construct building. We won't construct like that. So class is compulsory. Now, if you want to maintain 100 employees data, how many classes are required? 1 class only. 1 class only required. Okay. After creating a class, compulsory you have to create object. Otherwise, no use of class. Okay. Next heading, object. Next heading, object. It is an instance of a class. Object definition, it is an instance of a class. Object definition, it is an instance of a class. Now, what is the word instance? I'll explain. Next, write it. Syntax to create an object. Syntax to create an object. Class name, object reference equal to new constructor. Class name, object reference equal to new constructor. Class name, object reference equal to new constructor. This is syntax. See, example. Yesterday I given a class name. Something employee. Okay. Object reference something E equal to new. What is constructor? You will study later. Present constructor nothing but just a class name and brackets. That is called constructor at present. About constructor very depth later we'll study. Now just class name EMP, object reference E equal to new constructor. Like this you have to write. Now if you write like this, object created. Now here, what is EMP? It is a class name. What is E? Object reference. New. It is called dynamic memory allocation operator. We can call it a keyword also. It is keyword only. But suppose for loop, for is a keyword, but we are calling like a loop. While is a keyword, we are calling like a loop. Int is a data type, we are calling keyword also, like that. New is a keyword also you can call. But what is the concept is dynamic memory allocation operator. What it will do is allocates the memory. That point note down. New is called as new is called as new is called as dynamic memory allocation operator. And it allocates the memory to variables. New is called as dynamic memory allocation operator. Sorry. New is called as dynamic memory allocation operator, and it allocates the memory to variables. New is called as dynamic memory allocation operator, and it allocates the memory to variables. So dynamic, that means runtime. While executing the program, memory allocated. Say you'll compile the program javac demo.java. That is compilation time. You'll execute the program java demo. That is execution time. That execution time is called as runtime. That is only we are calling dynamic runtime, dynamic memory allocation. Runtime memory allocation called as dynamic memory allocation. While compiling, memory not allocated in Java. While executing, allocated. C, C++ different, Java different. C, C++ while compiling only memory allocated. C, C++ supports both compile time memory allocation, runtime memory allocation. But Java supports only runtime. See, in C, C++, pointers are there. Without pointers, if you write, compile time memory allocation. With pointers, if you write, runtime memory allocation. But Java, only runtime. But pointers are not there. These all implicitly pointers only. This reference nothing but implicitly pointer only. It doesn't appear star symbol, but it is pointer only. Implicitly pointers are present in Java, but we cannot write pointers. Explicitly not possible. Without pointers, programming language not possible actually. So they written with pointers only, but they didn't give a chance to programmers. Okay, so it is, that's what it is, dynamic memory allocation operator. Runtime only memory allocated. See, you are going to compile the program like this. See, you are going to compile the program like this. Javac demo.java. You are compiling. Okay, this is called compilation time. Compilation time in Java, memory not allocated. While executing like this, then memory allocated. That is called runtime. You are using Javac, that is compile time. You are using Java, that is runtime. While compiling, memory not allocated in Java. While running program, memory allocated. That is called dynamic memory allocation. But in C, C++, compile time memory allocation concept also is there. Runtime memory allocation concept also is there. Now, suppose you'll compile, memory allocated. You may not run. That memory wasted. No? You are not running, only compiled. Memory wasted in RAM. That's what Java developers, they prepared only runtime memory allocation. No compile time memory allocation in Java. Compile time, no memory. See, yesterday written class employee, integer employee number, no memory for that. While creating object only memory. Up to that, no memory. The object creation, runtime only. That means runtime only memory allocated. Here only memory if it is allocated, if you don't run the program, memory wasted. That is the reason while running the program only memory allocated. That is called runtime memory allocation. That is only we are calling dynamic memory allocation. That is new. New is an operator. It is other operators category, one operator. I given 8 categories of operators. No, they are new. It's a dynamic memory allocation operator. That is keyword also. Now, after this, constructor. Constructor later will study depth. Present constructor constructs the object. Constructor constructs the object. So new constructor, if you write, constructs the object and memory allocated. So new constructor, if you write, object created. That object referred by E. Now how it contains internally, I'll show you diagram. See, if you write like this, what will happen? See, in this line, first of all, new executed. In that line, first of all, new executed. New is a dynamic memory allocation operator. What it will do? It allocates the memory to variables. Yesterday I written variables. 3 variables I written. Employee number, name, salary. So those 3 memory allocated. So employee number, name, salary. Now see here, employee number, name, salary. That is allocated. Okay. So what in this line, in that line, first of all, new executed. So listen with more concentration, because otherwise you cannot understand subject further. Every class important yesterday onwards. Okay. New. It is a dynamic memory allocation operator. What it will do is, it allocates the memory. Okay. It allocates the memory to variables at runtime. That is only dynamic time. Okay. Now allocated. After allocating, constructor constructs the object. So it is object created. This is like a one entity. This is called employee object. Employee object. It is nothing but building constructed. Plan over plan. After that, building constructed. Plan nothing but class here. Object nothing but building here. Plan equivalent to class. Building equivalent to object. After making a plan, we will construct a building. After creating a class, we'll create object. This object. After constructing a building, you have to register with GHMC, no? You have to register with municipality. So then what they'll do? They'll give one house number. The number, it's like an address. Okay. Suppose here one address. Something address 1,01,000 address. This address stored in E. So here E. Here what will be there is this address. Like this. So after creating object, every object has an address. Every object has an address. The address, you will not get original address in Java. Security purpose, it is mapped into another code. So you will not get like a C language exact address. In Java, no pointers. You cannot retrieve original address. But what will be happen is here, every object has an address. The address mapped into another code. Internally mapped. Original address will not come. That is mapped into another code, encoded format. Another code. That code implemented with hashing technique. But what is hashing? Further I'll cover. Present not required. Further I'll cover. That code is called hash code. This is called hash code. This hash code returned. This hash code returned stored in E. Stored in E. So this is nothing but hash code. This is nothing but hash code. Now, instead of writing like this, what I'll do, I'll give one arrow. Now, further, I'm not going to write this type of code. Understanding purpose, today I'm writing. Further, what I'll do, only one arrow I'll write. That meaning, that object referred by this reference. Okay? You can represent in 2 ways. This address hash code you can place here. Now, this reference refer this object. With that number you can understand. Otherwise, with the arrow you can understand. Now, number we cannot predict. Which number is going to store, we cannot predict. That is the reason I'll write arrow. The arrow meaning this object address stored here. That is in Java we are not calling address. we are calling hash code. So every object has an address. That address mapped into another code. That code implemented with hashing technique. Then that code is called as hash code. That hash code written and stored in object reference. I'll give notes. Okay. Now, so now this is object reference, but few people they are calling that is only object. That is not an object. Object is right side. Object reference left side. So right side object created. That object referred by E. That is called object reference. Suppose for example, building constructed. After constructing, you will register with GHMC. They'll give a number. The number, house is referred by that number. The number is called house number. The number is called house number. Now, house number is a number or house? House number is a number or house? Number only, no? Object reference is a reference or object? Reference. House number means it is number only. House referred by one number, that is house number. But house number only people are calling house. Object reference only people are calling object. That is wrong. So this is not a object. What is E? Object reference. Now, what is EMP here? Class. Class name. What is E? Object reference. What is new? Dynamic memory allocation operator. What is this EMP brackets? Constructor. But where is object? Where is object? If you write like this, object created. If you write like that, object created. Now, here it is building. Before construction, are you calling building? No. Place will be there, raw material will be there. With that, we'll construct a building. But where is building now? Starting before construction, that is place and raw material. After constructing, this is building. Now, are you calling raw material now? No. Here also, it is new. It is constructor. Before writing this line, individually if you call, it is new. Dynamic memory allocation operator. It is constructor. But if you call both, that is object. Place, raw material. Place and raw material. After construction, building. But before construction, place and raw material. Individually, we will call it as place and raw material. But including both, after construction, it is building. That new constructor, individually. But new constructor, if you write, object created. Place and raw material, if you combine, building constructed. Like that. Okay? So, right side object created. That object referred by E. That's what that is called object reference. We should not call it as object. That is reference you can call. Either call object reference or reference. But you should not call it as object. Object is right side created. Right side created. New constructor if you write, object created. That object referred by E. So every object has an address. The address mapped into another code. That code implemented with hashing technique. Then that code is called as hash code. That hash code stored in E. So here what object contains? Data. What object reference contains? Hash code. So here object contains data. Employee number 101 and employee name, some name, and employee salary, like this stored. It is data. But data is present in object. Object hash code present in object reference. Now this diagram note down. This diagram note down. Just note down as it is. Is it over? So if you write like this, right side object created, that object referred by E, that is called object reference. Okay. Now I'll explain. Next, write it. Every object has an address. Every object has an address, comma, address mapped into another code, comma, that code implemented with hashing technique. Every object has an address mapped into another code, that code implemented with hashing technique. So that code is called as hash code. So that code is called as hash code. Here both object and object reference occupy memory. Object contains data, whereas object reference contains hash code. Both object and object reference occupy memory. Both will occupy. And object contains data, whereas an object reference contains hash code. So inside a object, data will be there. Inside a object reference, hash code will be there. Suppose if I write like this, give me answer. Like this, if I write, is it object created? Think yourself and give me answer. If I write only new constructor, object created or not created? Object created. Because right side part only object I said, no? Only right side part are written. Right? Just now I said, right side part is object. If you write like this also, object created. So if you write like this, what will happen? See, new dynamic memory allocation operator. It allocates the memory to variables. Like this, memory allocated. After allocating, constructor constructs the object. This is called object. Okay. Here data. Okay. Data. Here salary. Here suppose it is hash code. But this hash code not maintained. Object created, but that hash code not maintained. Building constructed, not registered with GHMC. Like that. Okay. Building constructed, not registered with GHMC. That type of buildings many are there in Hyderabad. Okay. Illegal buildings. Will they register? No. Like that. Your object created, that hash code not maintained. This type of object is called anonymous object. We can also call unreferenced object. Note down this one also. Anonymous object. We can also call unreferenced object. Anonymous object or unreferenced object. Anonymous object or unreferenced object. You can call it as anonymous object also. You can call it as unreferenced object also. Anonymous object or unreferenced object. So without object reference also we can create object. Without object reference also we can create object. That type of object is called anonymous object. We can also call unreferenced object. Okay. Is it over? Without object reference also we can create object. But this, what is the difference is this hash code not maintained. Sometimes this is also required. When we have to use this one, when we have to use that one, both I'll explain in a programming. Okay. Now think yourself and give me answer one more question. If I write like this, is it object created? No. Okay. It will not be created. If you write like this, what will happen? Only object reference created. Now, just now you studied object reference, what it contains? Hash code. Okay. But object is not there. House number will not be there. No? House is not there. House is not there. House number will not be there. No? That's what here null will be there. What is null? You studied literals. Literals. How many categories of literals? 6 categories of literals. What are those? Integer literals, floating point literals, character literals, string literals, boolean literals. This is object literal. So where we use object literal, here we use. Okay. So without object, you can create object reference. Without object, we can create object reference. Then which contains object literal null. If object is not there, hash code will not be there. Instead of hash code, null will be stored. Okay, write this one also. Null is object literal. Now, up to here, whatever I taught yesterday onwards, I'll ask some questions, give me answer. Okay? Then only we'll move further. Now, suppose 5 employees are there, 5 employees are there, 100 students are there. 5 employees are there, 100 students are there. These 5 employees data, 100 students data, I want to maintain in a system through Java programming. How many classes required? How many classes? 1 minute. 10 buildings you want to construct. Okay. 3 buildings one type, 7 buildings one more type. How many plans required? How many plans? 2 plans. Now, 5 employees are there, 100 students are there. I want to maintain 5 employees data, 100 student data. How many classes you have to create? How many? 2 class, no? Now you got a clarity, no? That is the reason general example. Okay? That is the reason general, but these general examples don't give in interview. Okay? No one will accept. This understanding purpose only. Okay. Now, so 2 classes required. Employees purpose 1 class, students purpose 1 more class. Because employee data, student data different. Okay. Employees salaries will be there, students marks will be there. But you cannot combine, no? And you cannot compare also. Student you can compare. Employee you can compare. But employee student you cannot compare, no? That's what 2 separate classes are required. Okay. 2 separate classes. Now, how many objects you have to create? Employee objects. 5 objects. 5 employees are there, no? 5 objects. How many student objects you have to create? 100 student objects. Okay. 5 employees objects, 100 student object. So 2 classes required, 105 objects required. 5 employee objects, 100 student objects. Okay. Clear, no? Now, one more question. Suppose one building I'll show you. 10 plans I'll show you. One building I'll show you. 10 plans I'll show you. The building based on which plan constructed? Can you identify? One building I'll show you. Suppose this building, 10 plans I'll give. This building based on which plan constructed? Can you identify or not? Yes or no? Yes. Here word instance. This building is an instance of this particular plan. This building is an instance of this plan. This building instance of that plan. Like that. This object is an instance of employee class. This object instance of student class. This object is an instance of department class. Like that. This object is an instance of bank class. Like that. That is a word instance. So, if I show building, if I show plans, the building based on which plan constructed, you can identify. This building is an instance of that plan. This object is an instance of employee class. So, first plan will be there, later building will be later building constructed. In between some incident happened, no? That is only instance. Instance word like incident. Like how you are going to construct your imagination, you are going to show real. That is instance word. Okay. Now, this object is instance of employee class. This object is instance of student class. Like that word instance. That is the word instance. Okay. Now, what is class? Collection of variables and methods. Will it class occupy memory? No. Will it file occupies memory? Yes. Class will write in a file. The file occupies. Okay. Now, what is object? Instance of a class. Instance of a class. Will it object occupies memory? Yes. What object contains? Object contains data. Object contains data. Object referred by object reference. What object reference contains? Hash code. Hash code. Can we create object without object reference? That type of object is called anonymous object. We can also call unreferenced object. Okay. Can we create object reference without object? Yes. That object reference, what it contains? Null. What is null? Object literal. Now, object is there. That object hash code stored in object reference. Suppose object is not there, hash code will not be there. Because hash code nothing but address type. In C, C++ we are calling address. In Java we are calling hash code. In Python language we are calling ID. Different terminologies they given. In Python we are calling ID. Java we are calling hash code. In C, C++ we are calling address. Terminology different. Okay. Now, without plan, there is no building. Without class, there is no object. Now, you take anything in the world, that is object. Now, example, monitor. Monitor is an object. Monitor is an object. For this monitor, definitely one plan was there. That is like a class. That is like a class. Why monitor shape is rectangle only? Why it is not circle? There was one plan. There was one plan already. Why mouse is like this only? There was one plan. Okay. Why keyboard is like this only? There was one plan. Why fan is like that only? Why tubelet like that only? Definitely there is one plan. So that means without plan, there is no building. Like here also, without class, there is no object. So how we are going to maintain data in a system? That is we are making plan. That is only class. How you are going to maintain? That is you are writing as a class. After class, you are creating object according to your requirement. So 100 employees data you want to maintain. How you want to maintain? You are writing class. After that, 100 objects will create. But class one only. Objects many. Like that. Is it clear? So this is about class and object relation. Is it clear? Any doubt? No. But it outlines only completed. Because class is a collection of variables and methods. But variables not completed, methods not completed. It is only outlines theoretical part. Theoretical part, just syntaxes. Okay? Now, next concept, variables. Now you will study variables very depth. Next studying variables. Now, note down. A variable is a container which contains data. This definition only you learn at the time. Okay? A variable is a container which contains data. This you learn. Types of variables. Types of variables. First one, instance variables. Second one, class variables. Third one, local variables. Say, for this topic, put more efforts, practice more and more. Later Java, nothing. Only this topic. If you are perfect in this topic, further Java, very easy. But if you are not perfect, further everyday difficult only. Because total Java depends on this topic only. If the person is saying advanced Java hard, that meaning is not perfect in this topic. The person is saying Spring is hard, is not perfect in this topic. The person is saying Spring Boot is hard, that meaning also this one only. Okay? The person is saying Selenium hard, that meaning also this one only. If you are perfect in this topic, remaining Java very simple. Remaining Java very simple. So this topic purpose, put more efforts, work hard, practice, practice, practice. Okay? So that too, huge demand is there for full stack Java developers. Right or wrong, you check it out. Present software market is booming. Huge demand is there. It is very easy to get a job if you have a skills. It is very easy. Full stack Java only. Okay? Only Java also requirement less as compared to full stack Java. Nowadays, every company asking full stack Java, full stack Java, full stack Java. Okay? Huge demand is there. If you have a logical skills, easily you'll get a job. Logical skills. That's what? Work hard for this topic. Whatever you studied remaining up to yesterday, that is C language. That is C language type only. Actual Java yesterday started. Class onwards. Object-oriented programming. Okay? Now, types of variables. First one, instance variables. Now, first, what is instance variable? What is class variable? What is local variable? These notes I'll give. Write it. A variable that is defined as a member of a class is known as an instance variable. A variable that is defined as a member of a class is known as an instance variable. Just note down notes. I'll explain with the diagrams. Memory allocated to instance variables. Memory allocated to instance variables whenever an object is created. Instance variables are stored in heap area. What is that? I'll explain. Just write it as it is. Second one, class variables. A variable that is defined as a static member of a class is known as class variable. Memory allocated to class variables whenever class is loaded. Class variables are stored in method area. Just as it is noted down, I'll explain with the diagrams. Local variables. A variable that is defined inside a method is known as local variable. Memory allocated to local variables whenever method is called. Local variables are stored in stack area. Every point important only. Every point important only. Okay? Note down. Instance variables, class variables, local variables. Three types of variables. Yeah, non-static variables, instance variables, static variables, class variables. I'll show you. I'll show you. With the diagrams, I'll explain. So as it is written, with the diagrams, I'll explain. Last two more points. Note 1. Local variables cannot be static in Java. Note 2. No global variables in Java. That means outside the class. No global variables in Java. That means outside the class. Is it over? No? Every point important only. Okay. Say a variable is a container which contains data. Suppose integer x equal to 10. We'll write x contains 10. X is a variable. 10 is a data. So x contains 10. Variable contain data. That's what we are calling like that. Okay. Three types of variables. Three types. First of all, how to identify. That is I'll explain. Okay. So a variable that is defined as a member of a class. A variable that is defined as a member of a class. That is called instance variable. A variable that is defined as a static member of a class. So member, static member. Only static keyword different. But what is static? Later. If the variable defined as a member of a class, that is called instance variable. A variable that is defined as a static member of a class variable. A variable that is defined inside a method, local variable. Local variables, if you write static keyword, error in Java. Outside the class, if you write variables, error in Java. Now, I'll show you. See, I'll show you. See, here. What I'll do is observe. Integer a equal to 10. Okay. Static integer b equal to 20. Here. Integer c equal to 30. Static integer d equal to 40. Here. Integer e equal to 50. Static integer f equal to 60. I written. Now, total how many variables I written? 6. I written 6. Now, you observe. First of all, a variable that is defined as a member of a class is known as an instance variable. Okay. Now you observe here. C is a member of demo class. C is a member of demo class. It is called instance variable. Okay. It is called instance variable. A variable that is defined as a static member of a class is known as class variable. A variable that is defined as a static member of a class. So static keyword is there, that is class variable. D is a static member of demo class. This is called instance variable. This is called class variable. Okay. Next, a variable that is defined inside a method is known as local variable. But methods not completed. Just a main method, you know, that is, you know. Now, not only main method, any method. Now, it is a method. Inside a method, it is a local variable. Okay. C is a member of demo class, instance variable. D is a static member of demo class, class variable. inside the main method, inside the method, local variable, inside the method. Local variables cannot be static in Java. So it is inside a method if you write local, but local variable if you write static keyword, error comes. So this is error. Okay, that is error. Now, no global variables in Java, nothing but outside the class, outside the class. So it is a class. These two outside, non-static also error, static also error. So here, this is error. This is error. Okay, this is error. Now it is valid. Instance method, instance variable. It is instance variable. Okay, it is class variable. It is also valid. Class variable. Okay, so it is valid. It is valid. Class variable. It is valid. Local variable. It is valid. Local variable. Okay, it is valid. Again, this is error. It is error. Okay. Now 1 minute. This is instance variable. Note on this one. It is class variable. It is local variable. Okay. This is not valid. Error. This is not valid. Error. This is not valid. Error. This is valid. This is valid. This is valid. Write this one. Instance variable, class variable, local variable. A variable that is defined as a member of a class is called as instance variable. A variable that is defined as a static member of a class, that is called class variable. A variable that is defined inside a method is called local variable. For local variable, if you write static, error in Java. Outside the class, if you write a variable, error in Java. Outside the class, non-static also error, static also error. Okay. It is non-static is instance variable. Static is class variable. Static variable, non-static variable. Okay. It is local variable. Here static if you write error. Here outside the class, static also error, non-static also error. Okay. Now, if I give one Java project, if I show one Java project, in that which are instance variables, which are class variables, which are local variables, if I ask, can you give answer or not? You can give no? Identification only completed. Okay, only identification. Okay, but when we have to use instance variable, when we have to use class variable, when we have to use local variable, what is the difference between instance variable, class variable, local variable? What is the scope of instance variable? What is the scope of class variable? What is the scope of local variable? What is the life of instance variable? What is the life of class variable? What is the life of local variable? How many ways to access instance variable? How many ways to access class variable? How many ways to access local variable? Okay, so many points are there. Okay, life, scope, accessing, everything. You should know very depth. Okay, so this is just identification completed. Identification. Okay, but instance variable place by mistake, if you write class variable, what will happen? Class variable place instance variable, if you write, what will happen? You have to select properly. Selection also most important. Okay, like depends upon application requirement, whether instance variable required or class variable required or local variable required. You have to select. Selection is most important. When you can select, if you know subject very depth, you can select properly. Okay, this is not completed. Only variables identification I given. Identification. Okay. Um, I posted Google class. I posted assignment 1. Okay. That is just I'll explain. That I'll explain. You have to do it. Okay. 1 week time I'll give. That is you have to do it. This is I'll continue tomorrow. This I'll continue tomorrow. Assignment I'll explain. This is one assignment. Okay. You observe total 11 programs are there. 11 programs. Okay. 11 programs. Today is Friday. So up to next Friday. 1 week time. Okay. 1 week time. Now, listen. I'll explain. You have to do it. Now, say, write a program to display factors of a given number. Write a program to display factors of a given number. See, but given number nothing but dynamically how to accept, like a C language scanf function. I didn't explain till, because that is object oriented programming required. That is the reason what you do in the program only, you take like this one variable. That is only accepting, like a given number means this is only given number. But this value dynamically, if you want to accept, we required system.in.read or scanner class, java.util package. Those all required. Then only possible. That's what. That will cover later. Present what you do, one variable write in the program only. Suppose a equal to 15. 15 factors you have to display. Now 15 factors means how to calculate factor. What are the factors? 1 is a factor. Next 3 is a factor. Next 5 is a factor. Next 15 is a factor. Divisible by, like if you write a reminder 0, division operation. So 15 factors, 1 to 15, one loop you have to write. If 15 is there, 1 to 15. 20 is there, 1 to 20. 300 is there, up to 1 to 300. One loop. In that loop, one number you have to check. Now, starting with 1. 15 modulo division 1. 1, 15 is 15. Reminder 0. So, this 1 is a factor. Now 2. 2 7 is 14. Reminder 1. So, it is not a factor. 3. 3 5 is 15. So 3 is a factor. Like 4 3 is 12. Reminder 3, not a factor. 5 3 is 15. So factor. Like this, next 15 comes. So out, if the number is 15, output should be 1 3 5 15. That is first program. So write a program to display factors of a given number. Suppose given number is 15, then output should be 1 3 5 15. That is your right. What you have to do? 1 to given number, you have to take loop. 1 number you have to check. Reminder if it is 0 comes, display. That is factors program. Second program, write a program to display sum of the factors of a given number. Same program, little bit change. Instead of displaying 1, 3, 5, 15, you have to add. These all you have to add. So 1 plus 3, 4. 4 plus 5, 9. 9 plus 15, 24. So first program output, if number is 15, output should be 1, 3, 5, 15. Second program output 24. If number is 15. Okay, number, any number you can take, but logic is same. That is second program. Third program, write a program to check whether given number is perfect number or not. It is also same type. Sum of the factors, if it is equal to given number, that is perfect number. Suppose for example 6. For example 6. 6 factors, 1, next 2, next 6. Okay. Now 1, 2, 3, 6. Except this number. Except this number. Now, if you add, what will get it? 1 plus 2 plus 3. Remainder, total 6. So, given number also 6. Some of the factors also 6. It is called perfect number. It is called perfect number. Okay. Now, suppose example, one more. 28. 28 factors. 1 is a factor. 2 is a factor. 4 is a factor. 7 is a factor. Next, 14 is a factor. 28. Except 28. Except 28. 1, 2, 4, 7, 14. 1 plus 2, 3. 3 plus 4, 7 plus 7, 14 plus 14. Same number, no? It is also perfect number. Okay. Now, so first program, display factors. Second program, sum of the factors, add. Third program, sum of the factors, if it is equal to given number, perfect number. Little bit change. Fourth program, write a program to display all perfect numbers between 1 and 1000. That logic, write in another loop, 1 to 1000. Then all perfect number displayed. Each and every number perfect or not, you have to check. If it is perfect, display. Fifth program, write a program to display all perfect numbers in a given interval. It is 1 to 1000, here any interval. 5 to 5000 or 500 to 10,000 or 10,000 to 1 lakh, whatever you want. So, program to program, little bit different, you observe. Okay. Like next, write a program to check whether given number is prime number or not. Suppose 7. 7 is a prime number. Yes or no? Yes. First, what is prime? Now 1 and 7. So it is also factors only. It is also factors related. You observe. 7 factors, 1 and 7. There is no other factor. 1 itself. 1 is a factor. Itself that number is a factor. Other factors will not be there. If there is no other factor, that is called prime number. 7 is a prime number. Suppose 13. Prime number. 1 and 13, no other numbers. So prime number. What you have to do? You have to write the logic. How to write? There are two ways are there. If only 2 factors are there, that is prime. Like that you can write logic. Otherwise, don't take 1, don't take given number, start with 2, end with -1. In between factor appears, break the loop. In between factor is there, break the loop. Display, it is not a prime. Like that also one more logic. 2 logics possible. Count the number of factors. How many factors are there? Count. If only 2 factors are there, prime. More than 2 is there, not a prime. Like that you can write one logic. One more logic. Don't take 1, don't take that number. Start with 2, end with given number minus 1. In between factor is there. Break the loop. Stop and display it is not a prime. Two different types logic you can write. After that, write a program to display all prime numbers in a given write a program to display all prime numbers between 1 and 1000. This logic you write in another loop, nested loop. 1 to 1000 one loop you take. One number, check it, prime or not, prime, display. Otherwise don't display. Eighth program, write a program to display all prime numbers in a given interval. It is fixed 1 to 1000. This is any range. 5 to 500 also, 1000 to 10,000 also, 1 lakh to 2 lakhs also, whatever you want. Next, write a program to display digits of a given number. Suppose, like this one number, display 5, display 4, display 3. Separate. Digits you make it separate. 345 is a number. Now, 345 modulo division 10. What will get it? 345 modulo division 10. 5 will get it, no? 5 separated. Again, 34 modulo division 10. 4 separated. Like that, 3. You can print. Until you get a 0. Stop. While a greater than 0. Or for loop a greater than 0. Like that you can write conditions. Okay? 3, 4, 5. Output should be either 5, 4, 3 also okay. Okay? After that, write a program to display sum of the digits of a given number. This is same little bit different. 3, 4, 5 you are going to separate. 3 plus 4 plus 5. Add. That is only sum of the digits. That is only sum of the digits. Next, write a program to display reverse of a given number. This number output should be 543. 345 you have to make it reverse. 543. How to make reverse? Take 1 5 into 10 plus 4. First 5 you take. 5. 5 into 10. 50. 50 plus 4. 54. 54 into 10. 540. 540 plus 3. Reverse. But writing program you have to put efforts. Okay? Now, the logic, how to write, I explained. You try to do it. If you don't get, I'll teach next Friday. 1 week time. So, those who are already familiar with C language, today only will complete. Okay? Just so today only will complete. If you are familiar with C language. And those who are not familiar with C language, it takes time. It takes time. That's what 1 week time I'm giving. Okay? Which one? Already logics I explained, no? If I explain, Friday class definitely will explain. Okay. Okay, you want program, one program. See. Here, what I'm saying is, you have to think. That is the reason I'm saying. If you ask, if now 11 programs in 5 minutes, I'll write. Okay? But what I'm saying is, you have to think. You have to write the code, you have to write the logic. Okay, one example I'll show you. Which program you want? Which program you want? Last program. Here, see, next second assignment also is there. Okay? Next third assignment also is there. Okay? Like this, weekly one assignment will be there. I explained, you try to write. If you don't write, definitely I'll teach all programs. Because each and everything if I explain, you will never get a subject. That is the reason I'm saying. Okay? These all programs, just 10 minutes I can complete. But you have to think. You have to think. Okay? You have to think. After getting experience, any program you can write. It is nothing. Logical thinking required. Now, suppose here total 11 programs are there. Those who are already familiar, today only they'll complete. Okay? Those who are not familiar, it will take 2 days. Some people, Few people 5 days will take. People 1 week also not possible. Because every student thinking power different, no? That's what 1 week time I'm giving. Even if you are below average also, you can complete by 1 week. If it is not possible, Friday class, this all I'll teach myself. I'll teach, but you have to think. Okay. So logic, so many logics I explained, no? With that knowledge, you can write. That is I'm saying. Okay. Now you try to write. If you don't get on Friday, these 11 programs I'll teach. Okay. You try to write. Why? What purpose I'm giving task to you? Thinking purpose. Okay. Now, not only this type. Further, see other assignments will be there. That is in system changed. Okay, other assignment. String handling program, multi-threading program, other assignments also. So many assignments I'll give. Okay. So weekly one assignment will be there. Up to last class, weekly one assignment. And a weekly one exam also will be there. That is also. Okay. We'll see. This all you try to complete. If you don't get, I'll teach. If you don't get, I'll teach. Sixth question, logic. What is sixth question? Prime number. Prime number, what you have to do? Counting number of factors. If only 2 factors are there, prime. Okay. Like that you can write. Count the number of factors. How many factors are there? Count. 2 are there, prime. More than 2 is there, not a prime. One more. Don't start with 1. Start with 2. End with -1. In between factor appears. Stop. That means break. Breaks the loop, no? Breaks the loop. That ideas also I'm giving. Okay. Suppose if I don't give this idea, it will take more time. I'll accept. But ideas also I'm giving how to do. At least you think coding part. Okay. So between 2, starting with 2, end with -1. In between, if any factor is there, breaks the loop. Then display it is not a prime. Okay. Like that. Try to do it. If you don't get, I'll teach. Next Friday, I'll teach all programs. Even if you don't get one program also, I'll teach. Okay. We'll see continuation tomorrow. No need to submit. No need to submit. Just you try to do it. No need to submit. Try to do it. I'll discuss on Friday. If any doubts are there, you can mail to my mail ID.